And finally, we have the theorem of Lagrange. The theorem of Lagrange is one of the most important theorem in group theory. What a generalization it is. It gives one of the most important means for the computation. It states, let G be any group and H be any subgroup of G. Then the order of H is a divisor of order of G. Next we proceed to its proof. Its proof directly follows from the properties of computation. It is the generalization of our earlier discussion. Now let order of G is n and order of H is m. Also let the number of cosets of H in G is r. Then by our previous discussion, each coset of H has m number of elements because order of H is m. Also we have these cosets are disjoint. They form equivalence classes. And these cosets they exhaust G. Therefore, we must have mr equals to n. There are m elements in cosets and there are altogether r number of cosets. Therefore, total number of elements in G is m times r because these cosets they exhaust G. And also we have the total number of elements in G is n. Therefore, we must have mr equals to n. This implies m divides n. M divides n. That is, m is a divisor of n. So, the order of H is a divisor of order of G and the theorem is proved. Next, we have an interesting corollary. It states, every group of prime order is cyclic. What is generalization? Proof, let G be a group of prime order, let the order of G be a prime number p, then the divisors of p are 1 and p itself. This means from the theorem of Lagrange, G can have subgroups of orders either 1 or p itself. The subgroups of G can have orders 1 or p itself. Now consider an element of G that is not an identity element. A is not identity element. Next we consider a subgroup generated by A. This cyclic subgroup generated by A is a subgroup of G. Now, what is the order of this subgroup? Because A is not E, the order of this subgroup cannot be 1. So, the order of this subgroup must be P. But we have the order of G is also P. So, we conclude that this cyclic group generated by A is the group G itself. So, G is the cyclic group generated by A and we have G is cyclic. The theorem is proved.